Good morning, everybody. I am going to be working through the odd problems on the review. That way you can see where the answers come from. So starting with number one. Number one is an exponential equation. So remember with exponential equations, the first step is to isolate. So we are trying to get this in the form b to the p power equals a. Then once it's in that form, we change it to logarithmic form, log base b of a e, and then we can solve for x. All right, so number one is step one's already done. It's already in the form b to the p power equals a. So step one, already done. Step two, we got to change it to logarithmic form. So in logarithmic form, it's going to be log base 5 of 29 equals x plus 3. So that's step two. Step three is to get the x by itself. So now to get the x by itself or solve for x, I'm going to subtract the 3. Now the x is by itself. So we have x equals log base 5 of 29 minus 3. Notice I cannot combine the 29 and the 3 because the 29 is part of the logarithm. So this is the exact answer. If we're approximating, because it's a base 5, we're going to need to use Desmos or some kind of calculator that has a logarithm. Let me clear what I got here. So remember to get to that from the keyboard, you go to functions and under miscellaneous, we can choose this one. So it was log base 5. I forgot what number it was. Log base 5 of 29. And then outside the parentheses, so I'm using the side arrows, minus 3. And we get approximately negative 0.907, or that would round to negative 0.91. All right, number 3 is the next one. Oh, you can hear my son. He's wanting some food. The next one is also exponential form. So we need to change it to logarithmic. Step one, we got to make sure the base and the exponent is by itself. So step one is to isolate. Step one is actually already done on this one as well. But it's in a little bit different order. On this one, the base is 8. So the 3x plus 3 is the power, and the 1/4 is the a. So when I change it to logarithmic form, it's going to be log base 8 of 1/4. So log base b of a equals 3x plus 3. So that's step 2, change form. So step 1 was already done. Step 2, change forms. Step 3, now we got to solve for x. So to solve for x, I'm going to divide by 3. So now I have 3x equals log base 8 of 1/4 minus 3. I just wrote the 3x on the other side. And then I have to divide the whole thing by 3. So we get x equals log base 8 of 1/4 minus 3 all over 3. Now, we're going to approximate this one as well, but when we approximate this, we just do have to be careful of the way we put it in our calculator. And I do need to use Desmos because this is a base 8, and most calculators only have base 10 or base E. So to Desmos. Now, I'm going to put the top in parentheses. So we had log base 8 of 1/4. Make sure I'm writing that right. Minus 3. Okay, and then that whole thing, whoops, I want that minus 3 inside the parentheses. Minus 3. and then the whole thing is divided by 3. All right, and so now we can see the answer is negative 1.22. All right, next problem is number 5. This is also exponential, just in this case, the base is e, and the negative 0.07 x is the p. So this one we do have to do step 1. So in step 1, we're trying to isolate the base and the power. So to do that, I'm going to have to do a couple steps. I'm trying to get this part by itself. So the first thing I'm going to do if I'm trying to isolate is subtract 30. So then we still have the 9 in front. So 9e to the negative 0.07x equals 6.3. So I subtracted 30. Then I still have to get rid of the 9 in front, so I'm going to divide by 9. So we get e to the negative 0.07x equals 6.3 divided by 9 would be 0.7. Okay, so that was step 1. We've isolated the base and the power. So then step 2, we want to change forms. So this is in the form b to the p power equals a. So I need to change it to logarithmic form. In logarithmic form, this would be log base e of 0.7 equals negative 0.07x. Now, hopefully we recognize that log base e is one of our special logs. So instead of writing log base e, that's our natural logarithm, we would write natural log of 0.7 equals negative 0.07x. All right, and then step 3 is to get the x by itself now. We're trying to solve for x. So to do that, I would divide both sides by 0.07, negative 0.07, I mean. And now the x would be by itself, so we got x equals natural log of 7 divided by negative 0.07. And again, we can approximate this. Most calculators, scientific calculators, should have a natural log button, but we can use Desmos as well. So if I'm using Desmos, we would have natural log of 0.7 and then divided by negative 0.07. And we get approximately 5.095. If I round that to 2 decimal places, that's going to be 5.10. All right, and number 7. Same thing, this one's exponential. So the first step is to isolate. This time the base, notice we have 2 times 10 to the 3x power plus 4 equals 90. The base is 10 and the power is 3x. So that's the part we need to isolate. So similar to number 5, we have to isolate that first. The first thing we got to do if we're trying to isolate is subtract the 4. But we still have the 2 in front. So we have 2 times 10 to the 3x power equals 86. Then to get rid of the 2 in front, we divide both sides by 2. So we have 10 to the 3x power equals 43. Now I change to log form. So step 2, change forms. In log form, this would be log base 10 of 43 equals 3x. Now remember, log base 10 is our common logarithm. So the way I would write this, I would just write log of 43 equals 3x. You don't have to write the 10 on a common logarithm. So that's step 2. Then step 3 is to solve for x. So on this one, to get the x by itself, I would divide both sides by 3. And then we would have x equals log of 43 divided by 3. And we can approximate that. Again, a common logarithm you should be able to do on most calculators. If we do it on Desmos, we're just using this one that just says log. We don't have to put in any base. So log of 43 divided by 3 is approximately 0.54. All right, so those ones were all exponential functions, so we had to change those all to logarithmic functions. So now let's look at the next section. These ones are all logarithmic functions, and we want to change these to exponential. So let's look at number 9. So we have this one. Step 1 is to isolate the logarithmic part. So on logarithmic functions, we want to get it in the form log base b of a equals p. Then we're going to have to change it to exponential form, which is b to the p power equals a. All right, so this one, number 9, is already has the logarithm isolated. So step 1 is already done for us. So this is the b, log base b of a. This whole thing is a equals p. So when I write it in exponential form, I'm going to have b to the p power. So 7 to the third power equals 4x plus. Now from here, we can change forms. So that was, that was step 2, change forms. Now we need to solve for x. If you want, you can evaluate 7 to the third power now, or we can wait till the end. It doesn't matter. So either way, I'm trying to get the x by itself in step 3. So now if I'm trying to solve for x, I would subtract 3. So we would have 7 to the third power minus 3 equals 4x. And then to get the x by itself, I would divide by 4. So this whole thing is divided by 4. So we have x equals 7 to the third power minus 3 divided by 4. Now 7 to the third power is a whole number. So we do want to give our answer. So again, you can use Desmos or you can use a different calculator. So 7 to the third power is 343. And then we had minus 3 is 340. And then that whole thing is divided by 4. To put this in correctly, I got to have that whole thing in parentheses and then divided by 4. So 7 to the third power minus 3 divided by 4 gives us 85. So x equals 85 on that one. Quiet, dude. All right, next one. Number 11. Hey, calm down. You're okay. Can you give me water? All right, we have 8 ln of 7x equals 13. Remember, ln is just a logarithm, natural logarithm. So we're going to do it in the same way. So step 1 is to isolate. This time we will have to isolate. So this is the logarithmic part, natural log of 7x. To isolate, I need to get rid of that 8 in the front. So right now it's multiplied, so to get rid of it, we divide. So I have natural log of 7x equals 13 over 8. Now this you could make it a decimal, but I'm just going to leave it as a fraction. All right, step 2 is we want to change forms. So remember, on a natural log, we have to know the base is e. So the base is e, this is the a, and then the 13 over 8 is the p. So it's in the form log base b of a equals p. So when I change it to exponential form, it's going to be b to the p power. So e to the 13 over 8 power equals 7x. So that's step 3 is to change forms. Or sorry, step 2. And then step 3, we want to solve for x. So to get the x by itself, now I just have to divide by 7. So now the x is by itself. So we have x equals e to the 13 over 8 power divided by 7. And then let's approximate that. So on a scientific calculator, you would have an e button, like right here. So e to the power of 13 over 8. Or if you're using Desmos, you can just type the E on your calculator and it uses our E. So E to the 13 divided by 8 power. And then that whole thing, whoops, is divided by, what were we dividing by? 7. Divided by 7. And we get approximately 0.725. If I round that, I'm going to say 0.73. All right, we got a couple more logarithmic ones. So 13, we have 3 log of x plus 5 minus 4 equals 2. So step 1 is to isolate. So again, we're trying to get the log part by itself. So if we're trying to get the log part by itself, I have to isolate this first. So I would add 4 first. Make sure you add or subtract before you divide by that 3. So we have 3 log of x plus 5 equals 6. Then I have to divide by the 3. And so then we'll have log of x plus 5 equals 2. Okay, so that was step 1, isolate. Step 2, we want to solve by changing, we got to change to exponential form. And remember, the logarithm that doesn't have a base listed is the common logarithm, so our base is 10. So the base is 10. This is the a, log base b of a equals p. So step 2, change to exponential form. So in exponential form, it's going to be 10 to the second power equals x plus 5. Now to solve this, where step 3 is to solve for x, I am going to subtract 5 from both sides to get x by itself. So now we have x equals 10 squared minus 5. This one we can evaluate. 10 squared is 100, and 100 minus 5 gives us 95. So x equals 95. All right. We got one more problem to do. Now this one is a little more challenging because as you can see, it's got 2 logarithms. So we still have to do step 1, which is to isolate. But the way we're going to isolate is a little bit different. In order to isolate this into one logarithm, we're going to have to use our properties of logarithms to condense. So that's what we did in 4C. So remember, the property we'd be using here, we have log base b of m minus log base b of n. So if I were to condense this into one logarithm, it'd stay log base 4. It'd be m divided by n. So x plus 3 divided by x. We have log base 4 of x plus 3 divided by x equals 3. All right, so that's step 1. So then step 2, we want to change it to exponential form. So this is in log form, log base b of a equals p. So when I change it to exponential form, Sydney, can you get my water, please? I'm going to change it to 4 to the third power equals x plus 3 over x. So make sure you change it to exponential form before you start trying to actually solve. All right, now this time I am going to go ahead and evaluate this number. You can use the calculator if you don't know what it is. 4 to the third power is 64. So we have 64 equals x plus 3 over x. Now, step 3 is to solve for x. This is where we have a little bit different type of problem because we have a fraction. Remember, we're going to have to get rid of the fraction. And the way we get rid of a fraction is we multiply both sides by x. All right, so I'm going to multiply this side by x and this side by x. Don't forget to do both sides. So the reason we do that is on this side, it gets rid of the fraction. And so then here we have 64x. And on the other side, now we just have x plus 3, and we don't have any other fractions. So now I have to solve. We're trying to get the x's by itself, but right now I have x's on both sides of the equal sign. So to solve that, I subtract the x from both sides. I need all the x's on one side. Remember, that's like a 1x. So 64x minus 1x is 63x. Okay, so we still have an x there. So 63x equals 3. Now, to get the x by itself, I have to divide both sides by 63. And so now we got x equals 3 over 63. You can reduce that to 1 over 21. You can also divide that to get a decimal approximation. 3 over 63 is approximately 0.048, we'll say. All right, so that one, the process was a little different because we had to, instead of just isolating, we had to actually condense so that we only have one logarithm. And then once we changed forms, we had a fraction that we had to get rid of by multiplying by the LCD. All right, so now you've seen one of each type of problems, and hopefully you can go and retry the other problems if you didn't get those ones correct. And then try the Google form problems, and you should be all set for your assessment.